Hello, welcome to our short introduction to MTG Secure Boot. Now, my name is Falco Strenske. I'm Executive System Architect for MTG AG, company located in Darmstadt, Germany. This company is focusing on PKI technologies and IT security technologies in general. So what is MTG Secure Boot? So the topic of Secure Boot is well-known. It's a well-known technology, Secure Boot. Here we are specifically interested in the Secure Boot technologies for embedded systems, which deviate in certain points from the conventional from Secure Boot for conventional computers. So here we know of a few frameworks deployed by chip vendors that enable secure boot technologies, that embed secure boot technologies already in the hardware. So we have trust anchors in form of public keys, typically embedded in the hardware, as it is the case, for instance, with NXP's HABv4 framework and other frameworks from that vendor. So the principle is very simple. After the chip starts up, the ROM firmware is loaded, which is unmodifiable and thus intrinsically secure. Then it verifies the digital signature on the bootloader using the trust anchor firmly embedded in the hardware, and then it loads the bootloader and starts it after the verification. The bootloader verifies the signature on the Linux operating system. Typically, it's a Linux operating system, not necessarily, of course. And then the operating system might verify the signature on applications. And how does MTG Secure Boot come into play now? The tools that are shipped by the chip vendors, they typically don't address the secure handling of the keys you use for signing the software. So during the development cycle, you need to apply the signatures on the different software components, bootloader, kernel, application, and possibly even the root file system. So what MTG Secure Boot offers is that you have a backend behind those tools provided by the chip vendors, typically interfacing the tools of the chip vendor using PKCS11, but also proprietary interfaces. And then the keys securely stored on this key management system, which the MTG Secure Boot basically is. This secure key storage is used for the application of the firmware signatures. Now, before we come to this next slide, I want to briefly show you the KMS. First, I want to show you the KMS, which is already a product of MTG for IoT devices, for instance, that are deployed solutions. So the new product we are developing is a specific variant of the Secure Boot, of the KMS, the Secure Boot KMS. And here we have to log in, we have to authenticate. In this case, there's just a single user in the final product. In the release, there will be different users with different access rights, the keys. I will explain a bit more on this later. Now, first we can view the so-called super root keys. This is how the NXP HABv4 framework refers to these keys, which are the issuer keys for the signing keys. So as you can see, we have 4 super root keys installed already. We can now use them to create signing keys. Choose a super root key. We enter a name, for instance, image I1 number 2. We choose key size, validity period, and generate the certificate. Now, as you can see, the key I just generated is down here. We look at the details, we can download the certificate. But the most important applications, of course, using it for signing. This is now a demonstration. In our final product, so the idea is that in the final product, a person is able to use this signing dialog to upload an image. In this case, it would be a kernel image. Choose the configuration options for the signature generation. For instance, determining which of the super root keys are included here in the hash table. So if you're familiar with this framework, you will know that you have to refer the super root keys that you are using on this chip when you generate the signature. So we create the signature, and we will be able to download the signed kernel. So this is how our product is conceptualized, and we come to the summary of the key features of MTG Secure Boot. So first and foremost, secure key handling. As I said, this is an established product. It is a HSM backend, so you can have secure key storage on the HSMs. You have in the final product, you will have role-based access rights. Unlike what you saw here, you will have different roles for different users. So you can have production keys, you can have testing keys available for different users. What is already existing in our product, the KMS solution, we have is flexible PKI integrated. It means we have PKI components that generate the keys for you, but you can also just use the PKI you have already in place and interface it with our Secure Boot KMS. The product will include command line interface, which is of course necessary for build system integration, for automatic generation of signatures during the build, but also web interface, not only for the key management, but also maybe for the signature generation for production releases, which you may not want to be automatically generated for security reasons. So I hope I could raise your interest in this new product of us. If you have any questions, please don't hesitate to contact our sales department, which will happily answer you. And we hope that we can provide the solution for you to facilitate your development processes regarding secure boot technologies. Thank you.